Okay, we're going to solve a nonlinear system of equations. So in grade 10, you did a lot of work with solving systems, but you did them only with linear. But we're going to do very similar strategies, just a little bit more complex math. So in grade 10, you did these things. You did substitution, elimination, and you graphed things to solve them. Does that ring a bell? You did those three things. Okay, substitution is when you have something alone and then you go plug it in and replace it. So I'm just going to rewrite this for a second. So here's my two equations. And if y is equal to x squared, does it make sense that I could just replace this y with an x squared? Does that make sense to you? If it's equal to x squared, I can replace it with an x squared. Okay, so that's called the substitution. Now it's just math. How do you solve something that looks like this? There's an x squared here, there's an x there. What do?
Make zero.
Zero. Zero it out. Make a zero. Okay, so x squared is the boss. So I'm going to leave it minus x minus 2, and then I have nothing left on that side. Okay, as soon as you ever see x squareds and x is involved, zero, right? Always think of zero. Now what? Does it factor? Simple trinomial methods. What multiplies to 2? You don't have many options. Negative 2 and positive 1. So x equals 2, x equals negative 1. Okay, but because we're solving for coordinates, I'm actually going to need this 2 comma something, negative 1 comma something. I need the coordinate now. So what do you want to do to get this part, which is the y? What do you think you do to get the y? How could I ever figure that out? If I know 2 is x, then what would I do? Plug it in. Does it matter if I pick this one or this one? No. Which one do you want to go with? Doesn't matter.
2.
This one? So what is 2 plus 2? 4. Or if you plugged it in here, what's 2 squared? 4. Doesn't matter, right? What is negative 1 when you plug it in? Negative 1 plus 2 is 1. Or you could have done this, negative 1 squared, 1. Okay, elimination. Okay, when you eliminate, you have to have things stacked on top of each other in columns. So I'm going to have to rearrange some stuff here so that they're lined up. So y equals x squared. I'm going to say so this is the y equals, this is the x squared column. We'll call this the x column, we'll call this the number column. Okay, so I'm arranging it in my columns. Are you okay if I just write 0x and 0? I'm also going to write 0x squared, just so I have a place in every column. Okay, what is the easiest variable to get rid of? Can you get rid of anything? If we put these together, could you eliminate any letter? Anything that would go? If you add or subtracted these lines together, would anything disappear? Heard somebody say subtract. What goes away if you subtract? The Y's are gone, which is what we want. We want something to disappear. Elimination is getting rid of one of the letters.
Yeah.
So y minus y is 0. This one had an x squared in it, subtract, and then I didn't have to subtract anything, so that's x squared. This one had no x's, and then I'd have to subtract an x. This one had no numbers, subtract 2 numbers. And what do you know? Look at this. We got to the same spot. Okay, so I'm not going to solve that because everything from there on out would be the exact same as we just did. But I'm showing you that there's multiple ways to do this. Okay, graphing. What do you know about y equals x squared? What shape does it look like? A line or a parabola? Those are your two things you've ever done in your life. Parabola. Where should I start it? 0, 0. And is there a normal pattern to this or different? Just x squared, so just normal, it's just a 1. So I'm going to do 1, 1. Then what else am I going to do? 2, 4, 3, 9. Okay, y equals x plus 2. What do you know about that from the past? What is it? What shape? It's a line, mx plus b. 2 is the what in this? Y-intercept. So there's my y-intercept. And what is the slope number? 1. So I'm going to write it as a 1 over 1 so that it tells me to do a staircase of up 1, right 1. Okay, so what is the solution? Where do they equal each other? So this coordinate and this coordinate is where they intersect. So the solution would be 2, 4. Ooh, look at that. It matched our algebra. And then this intersection is at -1, 1. So does this make sense from grade 10? What you kind of did, but with a little bit of a twist? Okay, number 2. Okay, there's 3 methods. And for this one specifically, one of the methods is the best pick. So what do you want to pick? Should we substitute something, eliminate something, or do you want to graph? Which one looks like the easiest method here? Elimination. Is there anything ready to be stacked on top of each other and disappear? The y squareds. They're ready to go. All I would have to do is add. So if I add these lines, I get 3x squared. Y squareds are gone, which is the part of why it's called elimination. And then the numbers make 27. Okay, algebra, divide by 3. X equals, how many of you are going to get this correct? Okay, my bet is that 75% of you didn't get this one.
Yes, I do.
Did you remember? Because think about it, what could you square to get 9?
-3.
Negative 3 works, positive 3 works. Okay. Now, what do you want to do? We got to get x now. What's always the thing? Once you have a variable, what do you always do? What's the strategy? Once you have one, plug-ins, plug-ins, plug-ins. Which line do you want to work with? Bottom one? So 2x squared plus y squared equals 22 is what we're going to work with. 2 times, what could we replace x squared with? 9. Because x squared right here equals 9. So I can just replace x. You don't need to write -3, positive 3 squared. Just go with a 9 because we know x squared is 9. Plus y squared. So 18. And subtract is 4. So y equals plus or minus 2. Okay, my advanced class actually just graphed things like this, which you will never do, but here's why we didn't pick that. This is a hyperbola. So the top equation looks like that. That's what it graphs like. And this one is an ellipse. So guess how many times they meet each other? 4. So this coordinate would be 3, 2, 3, -2, -3, -2, -3, positive 2. Okay? That's why the plus minus is important. There's actually 4 coordinate answers on that one. Okay? So don't forget your plus minus. Okay, next one. What kind of method would look the best? Substitution, elimination, or graphing it? I'm guessing none of you will pick graphing. But substitution or elimination? Which one? You can do either. I'm going to pick substitution just because we just did an elimination one. Here's what I'm going to do. I'm going to get just a y equals. So how would I get just a y equals? I'm going to subtract 71, right? Now I'm going to take that and I'm going to replace that. Once you have something alone, you can replace it into the other one. So I can replace that with that expression. So 5x squared minus 70 plus 4 equals x squared minus 2. Okay, what math are you doing here to solve this? How many variable types do you see? I just see one variable, right? There's just x squareds, so we're going to isolate. So let's do some grouping here. That makes negative 66. Are you okay if I do both of those at the same time? Or is that too much? So I'm going to minus an x squared, so 4x squared. And then this will be moving over there, so 64. Divide by 4, so 16. X equals plus minus 4. Okay. Now I need y. So what is y? Which one do you want to plug into here? Why don't we plug into this isolated thing? Y equals there. So I'm just going to rewrite it. So y equals 5 times, well, x squared. I may as well just replace straight with a 16. Is that okay? Because this line says x squared is 16. Minus 70 equals 10. So if I told you you had to write your answer with coordinates, how would you do it? If x is 4, y is 10. If x is negative 4, y is 10. There would be two coordinates like that.